On November 18th, 2025, parts of the internet simply stopped. Not one website, not 10, but millions. Twitter, ChatGPT, Spotify, Discord, Canva. Some of the most used apps on the planet suddenly became unreachable for people all over the world. Even sites that track outages like Down Detector were struggling at the very moment everyone needed them most. Hospitals had trouble reaching cloud services. Online stores lost sales. Companies watched millions of dollars disappear in just a few hours. For over 5 hours, critical services remained offline. And the wildest part? This global chaos started with one oversized configuration file inside one security system, inside one company that quietly powers the internet, Cloudflare. This is the story of how a single software module turned into a single point of failure for a huge slice of the internet. Every disaster has a story. Every failure leaves clues. Welcome to Stack Traces, where we investigate what went wrong. Cloudflare is one of those companies most people never think about until something breaks. But it's absolutely critical to how the internet works. It runs a massive network of data centers that sit between you and the websites you visit, handling security, performance, and traffic routing for a huge portion of global web traffic. Think of the internet like a giant shopping mall, and Cloudflare as the security guard at the entrance checking every single visitor. The guard checks who you are, decides whether you're safe or a potential threat, and only then lets you walk through the doors into the store you want to visit. But if that guard suddenly collapses, the doors don't stay politely open. They slam shut. Everyone, both good visitors and bad actors, gets locked out completely. One of Cloudflare's most powerful guards is its bot management system, which uses machine learning to score every single request. It tries to answer one simple question in just milliseconds. Is this a human or a bot? To do that job, it relies on a constantly updated configuration called a feature file, automatically built from data in an internal database system called ClickHouse. This file regenerates every 5 minutes. And here's the crucial detail that made this outage so devastating. That bot module isn't some optional add-on bolted to the side. It's wired directly into Cloudflare's core request processing pipeline. So when bot management fails, it doesn't just lose track of bots. It threatens everything that depends on that shared core layer. When it crashed on November 18, it took down websites, APIs, and even other Cloudflare products like Workers KV, Access, Turnstile, and parts of the dashboard. A single point of failure with massive reach. Late morning, November 18th, 2025. At exactly 11:05 UTC, an engineer deploys what looks like a routine permission change to Cloudflare's ClickHouse database cluster. Nothing about this deployment feels risky. The goal is straightforward. Tighten security by making certain database queries run under individual user accounts instead of a shared system account. It's a reasonable security improvement that's been tested and approved. Over the next few minutes, automated jobs keep running in the background, generating new bot feature files every 5 minutes, just like they always have. Everything appears normal. The monitoring systems show green. But now something subtle has changed. The query that builds those files starts returning duplicated rows from 2 different database layers instead of just one. The default layer and the underlying R0 shards are both being counted now. Same logical data, but counted twice. On paper, it looks like more data, maybe a good thing. In reality, it means the configuration file suddenly balloons in size, almost doubling its contents from around 60 features to over 120. By around 11:20 UTC, just 15 minutes after the deployment, monitoring systems start detecting something wrong. HTTP error rates are creeping up in different regions around the world. The first alarms begin firing. Inside Cloudflare's operations rooms, dashboards flash yellow, then red. Engineers scramble to their workstations, trying to understand what's happening. The initial hypothesis: this looks like a massive new DDoS attack, a hyperscale assault on the network from an unknown attacker. But the pattern is strange and confusing. Some services fail catastrophically, then briefly recover on their own, then fail again minutes later. Traffic drops sharply in Europe, while Asia seems fine. Then Asia crashes while Europe partially recovers. Something doesn't add up. By 11:28 UTC, the impact becomes unmistakable and terrifying. Major websites and services sitting behind Cloudflare's proxy start returning HTTP 500 errors to users around the globe. This isn't isolated anymore. This is a full-blown crisis affecting millions of users. Twitter explodes with complaints. Forum posts flood in by the thousands. Status pages light up like Christmas trees. People around the world are posting the same message. The entire internet seems to be broken. At first, engineers lean hard toward the obvious explanation. This has to be a sophisticated, coordinated, large-scale cyber attack stressing parts of their edge network. They start running DDoS mitigation protocols, looking for attack signatures in the traffic patterns. But as they dig deeper through logs, metrics, and correlation graphs, a different story starts to emerge. The failures aren't random. They align perfectly with the deployment of a specific configuration file. And that file isn't coming from customers. It's internal. It's theirs. To truly understand what broke, you have to zoom in on three critical layers that all failed in sequence. First, the database query, then the feature file it generated, and finally, the bot engine's hard safety limits that were designed to prevent exactly this kind of problem. Layer 1, the database. Cloudflare uses ClickHouse, a lightning-fast analytics database designed to handle massive amounts of data at incredible speed. It stores all the raw data behind bot detection features. This database has a specific architecture with multiple logical layers. This data lives in multiple logical places. There's a default layer at the top that acts like a view, stitching everything together for queries. Below that are the actual shards called R0 databases, where the real physical data is stored and replicated. Normally, a query only sees the default layer. That's intentional. After the permission change at 11:05, a metadata query that used to see just the default layer suddenly started seeing both layers, both the view and the underlying physical tables. Same logical information, just stored at different levels. But now the database is returning all of it, every row twice. That duplication silently inflated the output of the query that builds the bot feature file. What should have been a lean configuration with 60 entries suddenly became a bloated file with over 120 entries. Twice the size, twice the data, and nobody noticed immediately. Layer 2, the feature file distribution system. Every 5 minutes, like clockwork, Cloudflare automatically regenerates this bot feature file from the latest ClickHouse data and pushes it out to thousands of edge servers across its global network. It's a fully automated pipeline. No human review, no manual checks, just generate and deploy. Under normal conditions, this file contains approximately 60 features. These are the machine learning signals the bot system uses to evaluate each request. 60 features is lean, efficient, and well-tested. The system has been running smoothly with this for months. With the new duplicated database rows, that file suddenly contained roughly 120 entries. Some generations hit even higher. And because the ClickHouse cluster was being updated gradually across different nodes, sometimes the query hit a good node and generated a normal file. Sometimes it hit a bad node and generated the bloated version. Completely unpredictable. Layer 3, the safety limit. The bot engine has a hard-coded limit built into its core code. Maximum 200 features. This limit exists for a very good reason. The engine pre-allocates memory based on this number to stay fast and predictable. 200 was chosen deliberately as a comfortable safety margin, more than triple the normal 60 features. That limit was intentionally set high, well above normal usage. It should have been impossible to hit, but the bloated configuration pushed it right past that threshold. When certain edge servers tried to load the oversized file, they hit that limit and panicked. Hard crash. In Rust, the programming language Cloudflare uses, when a panic happens, the entire process crashes immediately. No graceful degradation, no fallback, just instant failure. Once engineers finally tied the failures to the bot configuration file around 13:37 UTC, more than 2 hours after the initial deployment, the immediate priority became simple. Stop the bleeding. Containment mode activated. First action, disable the automatic generation pipeline. At 14:24 UTC, they shut down the automated jobs that were creating new feature files every 5 minutes. Cut off the source of corrupted configs completely. Next, they manually pushed out a known good version of the feature file from before the incident. They identified a clean configuration from earlier that morning and forced it into the distribution queue, bypassing all the normal automated checks. Then they restarted the core proxy processes globally. In parallel, at 13:05 UTC, they implemented emergency bypasses for some dependent services. Workers KV and Cloudflare access were temporarily rerouted around the failing core proxy layer, trading advanced bot protection for basic availability. Sometimes you have to choose survival over perfection. As these changes propagated through Cloudflare's massive global network over the next 30 minutes, error rates began to fall. Traffic graphs slowly climbed back toward normal levels. By 14:30 UTC, most services started recovering. The internet was coming back to life. Full restoration came at 17:06 UTC, over 5.5 hours from first impact. Cloudflare immediately published a detailed post-incident report, acknowledging failures and committing to major architectural changes. This failure wasn't caused by hackers breaking in. It wasn't a power outage or fiber cables cut under the ocean. It wasn't a sophisticated cyber attack. It was caused by one configuration file that grew larger than expected, generated by their own internal system. And yet, because Cloudflare sits in front of such a massive portion of global internet traffic, that one internal problem looked to users everywhere like the web itself was fundamentally breaking. One company's bug became everyone's crisis. That's the power and the danger of centralization. It's a stark reminder that the modern internet, despite feeling distributed and resilient, is deeply centralized around just a handful of infrastructure providers. CDNs, cloud platforms, desk services, security providers. A few critical companies handle the majority of global traffic. Single points of failure hiding in plain sight. So here's the question we have to ask. Are we comfortable with this level of dependency? Or is it time to rethink how resilient the internet really is? Let me know in the comments. And see you in the next video. Gravity doesn't negotiate, and code doesn't forgive. Join us next time on Stack Traces as we decode another catastrophe.